Find the weight of a brick of mass 2 kilograms. Well, of course we've seen, right, that to work out the weight you've got to do the mass times the gravity, yeah, times the acceleration caused by gravity, okay, which is 9.8, okay, or we can write it as g. So 2g then will be 2 times 9.8, which is 19.6 newtons. So the weight of the brick is equal to 19.6 newtons. It says then, if the brick is suspended on top of the water in the swimming pool and is then released, if it falls through the water with an acceleration of 3 meters per second squared, what is the force of resistance of the water? Okay, well, if it falls through water, okay, the acceleration will be different, won't it? It won't be as much as 9.8, because if you think about it, that's what gravity, the effect of gravity has on an object. It'll fall at an acceleration of 9.8. But if it goes through a substance like water, it won't accelerate as fast because there'll be a resistance, yeah? So you know that when something goes through water, it falls at a much slower rate, and the acceleration here is 3. Okay, so what's the force of resistance of the water? So we need to model the brick. We need to look at the brick and think, well, okay, we've got the downward force of its weight, okay, which would be 2g, obviously 19.6, we saw that earlier, but the resistance then will be there. So we appreciate it's going downwards, so direction of acceleration is that way, and then we apply Newton's second law. Resultant force equals to mass times acceleration. So the resultant force will be 2g downwards. Take away then r will equal to then the mass, which of course is 2, because it's 2 kilograms, times the acceleration, which we were told was 3. So it's a case then of plugging that in. Well, we know that's 19.6, and we know this is 6, so rearrange this. We get 19.6, take away 6 is equal to r, so that implies r is equal to 13.6 newtons.